Friends, welcome to Power Tutorials. So today we're going to start surface areas chapter, which is chapter 12, and we're going to cover the concepts, that is important formulas from this chapter, along with the questions which are present in the math sample paper 2026 CBSE board. So from this chapter, so we have, it's completely like mostly of a formula based. Okay, so why I'm saying this, because we have total 1 2 3 4 5 6 7 other different, not 7, I think, yeah, only 6 we have. So we need to remember all 6 diagrams, not diagrams, I mean all 6 formulas. That is, we have surface areas formulas as well as volume formulas. You have to remember it. Then we can, using basic logics, we can solve any type of question which is related to 3D geometry. Simply I can say that. Okay, so total 3D diagrams, I will just go a little fast with respect to formulas, because these are already covered in various videos in my channel. If you want, you can also check. I will also try to keep the description in the comment section as well once this video is done. Okay, so I will just write all the formulas first. First one, cube. So what is cube? Cube is the 3D diagram which is having all sides are equal. So simply I can say, if you remember, if you ever played dice of Ludo, is considered as cube. Okay, which is perfect squares on all sides. Okay, so let's study surface area, that is lateral surface area, LSC. What is lateral? Lateral in sense we have to just exclude top and bottom, rest all sides we have to consider. Okay, so lateral surface area of a cube is 4a square, because it has 4 sides excluding top and bottom. If we consider top and bottom as well, then we consider as total surface area, which is equal to 6a square. 6a square because 6 faces are present. We call it as face. Sides, faces are nothing but sides here. So this 1, 2, backside 3, this backside 4, bottom 5, and top 6. Okay, this is LSC. We have to excluding top and bottom. So excluding top and bottom is considered as LSC when total surface area is complete, all the things, all the sides. Okay, so then we have volume formula. Volume is very easy, which is L cube. L cube or A cube, which is whichever is side. So here I have considered A as side, so A cube is the volume. Okay, next 3D diagram, which is cuboid. So cuboid is something like, cube is less squares in 3D. Same way, cuboid is nothing but rectangles in 3D. And example, I can say eraser, new eraser. Like if you bought a new eraser, definitely it will be in size of like this. Like for example, Apsara eraser, I can see, or Natras eraser, it will be rectangle here, and the same will be backside as well. Okay, this is one of the example of cuboid. So let's study what is cuboid formulas. LSA or lateral surface area is 2 into LB plus BH. Okay, let me change the color. LSC lateral surface area is 2 into LB plus BH, because I'm not considering top and bottom. Okay, whereas TSA will be 2 into LB plus BH plus LH. Okay, so here we're talking about length is this one, this is B, and this is height. Okay, so that's why we need to consider, not consider the bottom ones, bottom as well as top. I'm sorry, here LB is bottom and top, so it should be LH plus BH, not LB plus BH. If you consider LB, it will be bottom and top. So this way, for TSA, it will become LB plus BH plus LH. What about volume? Volume is again easy. It is there. It is A cube. Here it is all the multiplication. L length into breadth into height. So this is for cuboid. So I'm just writing the tanks. So cuboid is done. Then we have three curvy shape geometry box. Curvy shape 3D diagrams, which are first one. First I'll talk about sphere. So sphere, the example is very easy, which is ball. Cricket ball, I can say it is a sphere. So let's study about the formulas. So for sphere we don't have like TSS, ESS separately. We have only one, which is TSA, because bottom and top is not present for sphere. This one and this one are nothing, which is just an empty. So only thing which is TSA or CSA, it is only one, which is 4 pi r square. Okay, and then we have, as I told you, CSA or TSA, both are same. And then we have volume formula 4 by 3 pi r cube. Always remember, volume is cube, everything will be in cube, whereas for area it will be in square. Okay, why TSA and CSA both are same? Because as I mentioned, the top and bottom of a sphere are 0, so there is nothing. So then I will cover hemisphere. So what is hemisphere? Hemisphere is half of the sphere. If I cut sphere into two halves, then each half will be hemisphere. Okay, so for here, TS and CSA will not be same. Why? Because we have bottom part as well here. So first of all, let CSA. CSA is 2 pi r square. Whereas TSA, for TSA what I have to do? I have to add this bottom area, which is pi r square. So it is 2 pi r square plus pi r square. Hence, TSA of hemisphere is 3 pi r square. What about volume? Volume is half of sphere. Total sphere is 4 by 3. So half of sphere will be 2 by 3 pi r cube. Okay. So now we have two more, which are cone and cylinder. So these are very important because most of the questions will be related to, at least half of the question will be related to cone and half of the question can be related to cylinder. Okay, so cone is example, ice cream cone. Cone is just consider only the wafer, not the cream part. Okay, so the cone will be, I'm assuming this is a cone. Let's study the formulas. CSA says curved surface area or lateral surface area, both are same. Okay, so first I will write CSA, which is curved surface area, which is pi r l, where this is r, this is l, slant height is l, the normal height is h. So how to find l? Just a Pythagoras theorem. L is nothing but root of r square plus h square. Okay, what about TSA? TSA will be, we have to consider the top area, which is pi r square, so it will be pi r square plus pi r l, or simply pi r into r plus l. Okay, then we have volume. Volume of cone is 1 by 3 pi r square h. Got it? Now let's move to the last diagram, which is cylinder. So cylinder is something like this, and best example is drum, something like this. Generally the drums will be open on the top, but if you consider just as closed drum, then that the diagram is nothing but cylinder. Okay, so what are the formulas for cylinder? Okay, first of all, let's CSA, which is curved surface area, is 2 pi RH, whereas total surface area, as I told you, have to just add top and bottom to this. Top is again pi r square, bottom is again pi r square, so pi r square plus 2 pi RH. So it is 2 pi r square plus 2 pi RH, or simply 2 pi r, if I take common, it becomes 2 pi r into r plus h. Okay, and then what is the volume of cylinder? Is pi r square h. Yeah, hi Rajneesh. Trigonometry is already done. You can check in my live section videos. I have done the trigonometry part already. If you have any specific question you want to solve, you can post that question here. I'll definitely check and answer that question again. Whichever the questions are there in the sample paper, those are already covered. So trigonometry I have done in which video I'll just explain. Yes, around 12 days ago I have completed trigonometry part. Chapter 6 trigonometry, it is done. But as Rajneesh, as I mentioned, if you have any specific question you want to get from me, you can post that question in comment section or else in the community post. Directly just post that image and tell me to explain that question. I will definitely check and answer to it. But the sample paper questions of trigonometry are already covered. Thanks for joining. Okay, let's continue this sample paper questions of surface areas and volumes now, because as of now the formulas have been covered. So total 6 marks weightage has been present in sample paper, and as per previous year questions also I can say at least 4 marks will be coming from this chapter. Okay, so that's why I'll say it is 4 to 7 marks weightage will be coming from some surface areas and volumes, and mostly questions will be at least 1 4 mark or 1 5 mark will be coming from this chapter for sure. Not only 1 marks or 2 marks or 3 marks, 4 or 5 marks questions will be coming from this chapter. Okay, so in the sample paper also they have provided 1 MCQ and 1 5 marks question. Okay, so let's solve the MCQ question first. If the area of the base of a right circular cone is 51 centimeters. So here to understand which area they have provided. TS, it's not TSA or it's not CSA. It is the area of base. Okay, so if I explained in the cone part, I had told you, so this is one area, whereas CS is another area. For TSA, what I have added? I have added the top area, that is the base area, plus pi RL. So here they have mentioned base area, so simply they are mentioning pi r square area. Pi r square is 51 centimeters. The volume they have mentioned, what is the volume of cone? I'll just show the formula again. Volume of cone is 1 by 3 pi r square h. So let's apply this formula. They ask volume they have provided 1 by 3 pi r square h. They have provided the value is 85. So simply just substitute pi r square as 51. So this becomes 1 by 3 into pi r square is 51 and h is equal to 85. So simply divide by 3, 3 ones, 3 sevens, 17 5s are 85. So the height is nothing but 5 centimeters. It's a very easy question, but it's not like a direct question I can say, because no one will think about the base area is pi r square. Just simply think about pi r l or pi r l plus h. But then I haven't mentioned pi r l or pi pi r into r plus l, they are talking about base area, which is just nothing but just a circle. They're talking about this circle. So this is the base area, which is a circle. So base area of circle is pi r square. Okay. Let's solve the 5 mark question. So here they have mentioned A or B. So whichever you feel confident, you can solve in exam. And my suggestion, if you have A or B such that one is surface area and one is volume, then I always suggest to go for volume first. Don't think about surface area. And if you have confidence, if you want to solve, you can solve the surface area later. Why I am suggesting to go for volume question instead of surface area? Why? Because there can be cases due to the exam pressure or tension, you might miss the inner portion of the hidden part. Like suppose there can be one A diagram and they say that B diagram has been cut from it. Then in the exam pressure you might miss the inner area. Okay, so you might think about the total outside areas, but there can be cases due to the example you might miss the inner area, so there can go, the question might go wrong. So but whereas for volumes there is no need to check for inner portion or something, it will be simply total area minus the cut part area, or else total volume minus the sphere or cone or cube or whatever it is cut. So here there will be no surface part, but here it will be surface part. Okay, if there is an option, I suggest to go for volume. If there is no option, then yes, there is no other go. Whichever the surface area question, make sure you're checking whichever the part properly, and then we are finding the exact answers. Okay, let's start. So from a solid right circular cone. So we have a cone. I'll write the diagram here. From a solid right circular cone whose height is 6, radius of base is 12, this is 12, a right circular cylindrical cavity of height 3 centimeters and radius 4 centimeters is cut such the base of cone and cylinder concentric. Okay, so base is exactly constant, so I'll say this is a cylinder which is cut such that this is this base and the base of cone are concentric. Okay, now this is a cylinder with radius as 4 and height as 3. This height is 3. Okay, now let's see what they are asking. Find the surface area of the remaining solid. Okay, now this is interesting. So I will just draw the point surface totally with pink color so that it will be clear to understand. So to if you suppose we have a full cone and a cylinder has been cut. So what is remaining, I will draw it here. So remaining are, first we have this entire portion, outside portion, and then we have this entire portion, and from bottom we don't have the complete, so whichever area we have, this is the area outside which is remaining, because the inside one circular part has been cut. Okay, and then you need to consider this area, this part as well, this part and the remaining part and this part. So the pink portion is nothing but the surface area. We need to find the surface area of that part, not the inside part. So I'll just shade it this part again. Okay, we need to get the surface area of this. So we'll start from here, go here. So from bottom we need to from the complete bottom circle, you need to eliminate the inner cylinder part circle and then do it. So but don't draw in exam in all this part, for just for explanation I have drawn it. Okay, I'll draw that main diagram again. So the main diagram is something like this. We have a cone and we have a cylinder, such that the bases are concentric circles. Okay, now so for this we need to do step by step. So first let's find out what is the slant height of the cone, because for surface area we need to find the L value as well. Okay, so first we'll find the slant height of cone, because each, as I told you, we have step marking in our CBSE board exam, so each step is important. Slant height of cone, which is nothing but root of r square plus h square. What is radius? They provided 12. H they provided as 6. So which is 144 plus 36, which is root of 180. So it becomes, if I take into 4 into 5, so this becomes 9 2s are 3 2s are 6, 6 root 5. Okay, how I got 6 root 5? Because 180 I can write it as 9 into 4 into 5. So 9 square root is 3, 4 square root is 2, 3 2s are 6, and the remaining is root 5. So we got the slant height, and this will carry at least weightage of half mark. Okay, now let's consider about areas. So first we'll cover outside curved surface areas. Okay, so first we'll find CSA of cone. So what is CSA of cone? Which is pi r l. So we got L value also. So pi into R value is 6, L value is 6 root 5. So we got the slant height, CSA of cone as 6 into 6 is 36 root 5 pi. So this carries 1 mark. CSA, the outside part is done. Now we had to go to the inside. So I mean the bottom part. I will write here bottom surface area. So what is bottom surface area? Surface area of cone minus surface area of cylinder. Bottom surface area I'm talking about. Okay, so what is the bottom surface area of cone or cylinder? Both are circles. So here it is pi into cone surface radius is 6 square minus cylinder surface radius is 4. So the bottom area is 36 pi minus 16 pi. This carries another 1 mark. Now the inside area. This is very important. So for inside area, we have to go from here and this circle and again here. Okay, so I'm repeating again. For inside part, we have to go. We have two. The lateral surface area of cylinder plus one surface of which is circle. Okay, so lateral surface area of cylinder is 2 pi RH. 2 pi r is how much? Cylinder r is 4, height is 3 plus the top one which is again circle, which is pi r square. So this becomes 4 3 is 12, 12 2 is 24 pi plus 16 pi. So this area is again 1 mark. Now we have to add all this to get the total surface area. Total surface area will become, first CSA of cone how much? 36 root 5 pi plus base area 36 minus 16, which is 20 pi plus the bottom area 24 plus 16, which is 40. So simply if I take pi as common, I will get 40 plus 20 is 60 plus 36 root 5. Let me check the calculations once again. Radius of cone is 12. Okay, I think I made a mistake. I'm sorry, let me just correct it. So make sure you're doing the values proper, or else even a small mistake can go wrong. Okay, so slant height of cone is fine. and then CSA of cone, which is pi into r into L. R of cone is 12 here. L is okay, 12 6 is 72, so it should be 72 root 5. Okay, and then we have next part, bottom surface area, which is pi into 12 square, so it is 144 pi minus 16 pi. Okay, so 144 minus 16 is how much? 128 pi. Okay, what about inside area? Inside is for cylinder only, so cylinder radius is 4. Okay, height radius is 4, height is 3. Okay, so this is no change, and this is also correct because it is the radius of cylinder. So it is 24 pi, 4 3 is 12, 2 is 24 pi plus 16 pi, which is 40 pi. Okay, so this is correct. Now let's write the total. 72 root 5 pi plus 128 pi plus 40 pi. So if I take pi as common, I will get 128 plus 40 is 168 plus 72 root 5. Okay, so in this way the total surface area has been found. So that's why I told, so we need to check slant height, inner area, outside area, and then we'll get the final values. Okay, so this I think it will carry 1.5 mark or 1 mark if it is step marking for another steps. Okay, let's solve the last question, which is B part. So this is a volume question, so here the calculation will be little lesser when compared to surface area questions. Okay, let's solve this. An empty cone of radius 3 centimeters and height 12 centimeters. So we have a cone which is radius how much? 3 centimeters and height is 12 centimeters. Okay, filled with ice cream such that the lower part of the cone is 1/6 of the volume is unfilled. So 1/6 is empty air here. Okay, but the hemisphere is found on the top. So it's an ice cream cone which is having a hemisphere on the top. Find the volume of ice cream. So simple. So total volume of ice cream will be 5/6 of volume of cone plus volume of hemisphere. So make sure you're writing this step as well, because this step also carries half mark or 1 mark, because this is the main important part. Okay, now the next part is important, easy. Just we have to substitute the formulas. So the volume of cone is 1/3 pi r square h plus what is the volume of hemisphere? It is 2/3 pi r cube. So 5/18 into pi into what is the radius of cone they have provided? Radius is 3, height is 12. Radius is 3, height is 12 plus 2/3 pi. The radius will be same because the hemisphere is on the top of the cone. So again the radius is 3, so it is 3 cube. So let's do some calculations. So it is 6 2s are 12, 6 3s are 18, 1 3 and square gets cancelled out, 3 2s are 6, 6 5s are 30, 30 pi plus here 1 3 and this cube can cancel out as 3, so 9 2s 18. So this becomes 48 pi is the final one. So now you can understand why I am saying that if they have two questions and one is optional part, one is surface area and another is volume, then always go for volume first, and if you have time you can also go for surface area as an optional part, but I always suggest if there is an option between surface area and volume, go for volume, because volume will take less time and it will be, the answer can be more accurate when compared to surface area. Okay, so in this way you can also stop it here, but in the question they haven't mentioned in terms of pi, so simply you can also multiply with 3.14 and get some closest value. So let me multiply it. 314 48, 8 4 is 32, 3 8 1 0 8 9 10 11, 8 3 is 24 25, 4 4 is 16 1, 4 1 is 4 5, 4 3 is 12. So it is approximately 150.72. centimeter square. Unit is also important. Let me check the calculation because this step is important. 48 into 31, 4 4 is a 32, 3 4 8 1 0 8 9 10 11 8 3 is 24 25 4 4 is 16 1 4 1 4 5 4 3 is 12 correct 2 7 10 5. Yes, calculation is fine. It is 150.72 centimeter square. So in this way all the questions related to surface areas of surface areas and volumes of sample paper question has been done, and also pasted the formulas related to all the important 3D diagrams, that is 6 3D diagrams, which are cube, LSA, TSA, and then volume formula, and then also explain cuboid, LSA, TSA, and volume formula. Sphere formulas, TSA, CSA both will be same because the top and bottom of a sphere is 0. So simply TSA and CSA will be same, and then we have volume formula, and then you have hemisphere, which is half of sphere. CS is 2 pi r square, TS is 3 pi r square, because we have a base here which is pi r square. Thus with the CSA 2 pi r square plus pi r square becomes 3 pi r square, and then we have volume which is 2 by 3 pi r cube, and then we have cone pi r l, and then L is root of r square plus h square, and then TSA we have which is pi r square plus pi r l, which is pi r into r plus l, and then you have volume formula which is 1 by 3 pi r square h. Okay, and then last one is cylinder. CSA 2 pi r h, TSA 2 pi r square plus 2 pi r h, or else 2 pi r into r plus h, and volume formula is pi r square h. So you have to remember all these formulas, and easily we can solve any question which is present in any question paper. Okay, so in this way the sample paper questions has been solved, and that tip I have provided is, if you have an optional question, that is either solve surface area question or volume question, then always go for volume question, because volume question when compared to surface areas is the calculation part will be smaller, and you will have much confidence whether you did right or wrong when compared to surface area questions. Okay, so thanks for watching. So in the next video we'll cover the sample paper along with the concepts of chapter 13. So 3 more chapters are remaining, 13, 14, 15. We'll try to cover within 3 to 4 days, and then we'll start with previous year question papers. Okay, so now it is almost October now, and I hope most of the schools might have completed almost their syllabus, and they will be mainly focused on previous year questions and important questions and revisions. So we'll also do the same. We'll mainly focus on previous year question papers one by one, that is 2025 paper or 2024 paper. Such things will cover, but after covering the science paper solutions. So till now maths almost 3 chapters are remaining. After that we'll start science paper sample paper solution, and then we'll start with the revision. Okay, so thanks for watching, and let's meet again tomorrow or day after tomorrow around 1 or 1:30 p.m. in a live session. Thank you.